Hello and welcome to our last block in the tutorial session around busbar protection. And today we are going to focus on the distributed SIPROTEC 5 protection and maintenance functions. I'm Michaela Münekes. If this is not the first electrification and automation webinar you joined, you might already know me, and I'll be your guide through this webinar for today. So let's start with a short glimpse into the agenda. What can you expect from us today? We will start with a short recap of former webinars, a really short one, because then we dig deeper into the topics of communication technology and the SIPROTEC 5 online configurator. That will be with Rainer. Then you will see how to configure a distributed busbar protection with a 7SS85CU in DIGSI 5. Pardon? Yeah, that's okay.
Just here.
And then it's, so it's not only me picking from the paper right here, but it's also you that will be able to take a short glimpse into the agenda. Because as I already continued, you will see how to configure a distributed busbar protection system. And then we will close today's meeting and this webinar tutorial series with the busbar protection maintenance and supervision functions. And now we are a bit curious. We like to learn from you. How many of these 4 webinars did you participate in? Is it the first one? There you go. Is this the first one you join in? So you just dig directly into the distributed busbar protection? Is it already a second one that you join? Or will this be even the 4th one that you take part in? And if everything runs well, you can now see the poll on the right-hand side, and we invite you to to just hand in your information there. And so, yeah, it looks quite nice. So it's a bit of a mixture. I'd say that for each, we have about a quarter of the attendee rate. So that's why we will start with a short recap to get you on board. And we already tested how it works. If you are a bit interactive with us, please continue to do so. There is the question to the speaker field in the upper right corner. And if you type your question there during the presentation, I will be your voice in each of the breaks, and then the experts will be hopefully able to answer your question. So I will read your answer during every break, and we'll hope to see, I will read your question, and we hope that we receive an answer. And by now, I've mentioned quite a few times the experts. So I'm really happy that today here in the studio are once again my dear colleagues, Rainer Goblirsch, definitely a specialist on busbar protection devices and a member of SIGRE and IEC working groups about busbar configurations and process bus and requirements. And then we have Nina Hühn with us, not only a promoter for differential protection, but definitely an experienced SIPROTEC engineer. And those two will share their knowledge once again with you. So please remember to make use of your chance and ask the experts directly via the question to the speaker field. And I think by now it's time to start into communication topologies. So Rainer, the stage is yours.
Thank you, Michaela. Hello, also from my side. Experience the communication topology of distributed busbar protection. But as I learned also, according our poll, not everybody of the audience today has followed all our other 3 tutorials. So I will do a short recap. It was from the first tutorial when Nina explained in detail the different types of 7SS85. You know, we can do both a centralized busbar protection and different types of distributed busbar protection with our 7SS85. And before I will go to the communication topologies, I will give this short recap. Let me start with the first type of the 7SS85 busbar protection. Its first type was the centralized busbar protection. It has different types, significant feature 9 and A to E. It starts with only one zones, and the maximum, the biggest one, is a significant feature D, which covers up to 6 zones and a maximum of 20 current measuring points. The essential of a centralized busbar protection is that really all process signals are directly connected from the process, from the primary substation to the device 7SS85. Already said, the maximum are 20 CDs. One CD in the 7SS85 is always 4 analog inputs for phase A, phase B, phase C, and the neutral current. So that means in maximum 80 analog inputs, 20 CDs, that's the maximum. That is the maximum of SIPROTEC 5 analog inputs in it all. And also one limitation is the maximum is 6 independent bus zones. We have the function group busbar, where we have also the busbar protection functionality. So we have a function block check zone for the check zone protection, and we have for each independent bus zone, for each independent measurement system, a bus zone. And very essential inside this function group busbar are the busbar protection algorithms located. The busbar protection algorithm I explained in detail in tutorial 2. Optional, we can have we can have a circuit breaker protection functionality, which will be located in the function group circuit breaker. Or let's start, we have one big function group, one container. We call it the bay for each primary bay. And also for each feeder bay, we have a bay for a coupler bay. And we have inside each of these bays, we have a function group for the current transformer, for each disconnector, and we have a function group for the circuit breaker. Inside the function group circuit breaker is a circuit breaker failure protection located. And for additional backup functionality like overcurrent protection and directional overcurrent protection, we can also create a function group voltage current. Essential also that we have a very easy engineering for our centralized busbar protection. The engineering I showed in detail 5 weeks ago in our third tutorial. As always, say the centralized busbar protection is, if possible, is because of the lower hardware effort, the lower number of devices, it's the most cost-optimized solution, as all functionality is in one device. Based on these types of the centralized busbar protection, we have our first, how to say, type way to do a distributed busbar protection. We call it the IEC 6150 compliant distributed busbar protection, the compatible distributed process connections. This type is using, that is very essential, the same types like the centralized busbar protection, the significant feature 9 and A to E. Here, because we have no longer the limit of the maximum analog inputs in SIPROTEC 5, it's not more possible anymore because of the hardware. So with this type, we can cover up to 24 current transformers. 24, this limit is no longer because of the SIPROTEC 5 hardware, it's because of the memory consumption in this one big centralized busbar protection device. And also we have the same limit, we have a limit of 6 bus zones. The difference, of course, to the centralized busbar protection is that now all process signals are not connected to the central 7SS85, but they are connected to the merging unit, to the bay units. Here you can see, here we have the 6MU85 as a dedicated bay unit, but also you can use a 7SJ85. You can use any modular SIPROTEC 5 device as a bay unit. And here you will connect your disconnector positions, your circuit breaker positions, and your current information to the merging units. And then this data will be transmitted via the process bus IEC 650-9-2 to the central 7SS85. Essential, as it is anyway the absolutely same device, that we are using absolutely the same algorithms. We have the same function group busbar with a function block check zone, with a function group bus zone 1 for bus zone 1, and so on. So you can absolutely trust on also test you have done with the centralized busbar protection, because it's really the same type. Also, according backup functionality, circuit breaker failure protection, overcurrent protection, directional overcurrent protection will be, you have here two possibilities. You can either create them in the merging unit, or you can create them in the base, like in the centralized busbar protection in the 7SS85. But to reach a maximum of 24 current transformer, it's essential to create each backup functionality which is possible in the merging unit and not in the 7SS85 central unit, because of the memory consumption of the 7SS85. The only exception is the end-fault protection. The end-fault protection in this type of distributed busbar protection must be located in the 7SS85. A big advantage of this approach is also that in this approach you cannot use only SIPROTEC 5 merging unit, 6MU85 or any other modular SIPROTEC 5 device. You can also use compliant merging units from competitors. You can use a merging unit from GE, from NARI, or from any way. Important is they have to support IEC 650 revision 2.1. That's essential. Important is that also for this distributed busbar protection type, all communication topologies can apply. I will explain later. The centralized busbar protection in the hybrid process connection is very easy to explain. I will do it quite short because it's only a recap. It's simply a mix of the centralized busbar protection and the IEC 650 compliant distributed busbar protection. So some feeders are used as in a distributed way. That means the process signals are connected to bay units, to merging units in the field. And some signals are directly connected to the 7SS85. As we have here at least one bay, which is completely located in the 7SS85, here we have the limit of a maximum of 20 bays and not anymore 24 bays. That's really essential. So typically this configuration, this hybrid, will be done in the application that we have a direct process connection in any coupler. So the 7SS85 center unit will be located in the coupler. And on the outgoing and ingoing feeders, we will have a distributed approach where the merging units will be located in the base. Let's come to our final type, our newest type, the fully distributed approach, where we have different types of the 7SS85 compared to the centralized and to the IEC 650 compliant solution. Here, all process signals must be connected to the bay units. With this approach, it is possible to have a maximum of 48 current transformers, and we have a maximum of 20 bus zones. Very essential. This approach is using the same function group busbar, which I could say is more or less the heart of the busbar protection. So we can be absolutely sure that we are using the same algorithms with the same checksum protection, with the same bus zone. It's really absolutely the same code we are using, really the same functionality for the basic functionality for the distributed busbar protection. It's the same like in the IEC 6150 compliance solution. Any modular SIPROTEC 5 device can be used as a bay unit. What is not possible in this approach is really because of the automated and easier engineering to use third-party merging unit in this approach. And also, and that's a little bit what I have already mentioned, because we are using in this approach only Siemens merging units, Siemens bay units, 6MU85 or any other modular SIPROTEC 5 device, it is possible to have an integrated system engineering, a very easy engineering. One mention. What is really essential and what is the root cause that it's now possible to have a maximum scope of 48 CTs of 48 bays and 20 bus zones, that here in this approach we will not have this big base with this big function group circuit breaker inside, the big function group disconnectors and so on, but we will have only small bay proxies, proxies for the disconnectors, proxies for the circuit breakers. This means we will have mainly the most important signals. We will have here signals for the position of the disconnectors. We will have signals of the position of the circuit breaker, of a retrip T1, of a retrip T2, versus the end-fault protection. So really much smaller, not so much memory consuming functionality inside the base. Important is also during this integrated busbar protection system engineering, all these proxies will be automatically be created. This will Nina in her demonstration show later. Okay. Important, before I go now to the communication topologies, is that both for the fully distributed busbar protection and for the IEC 6150 compliant distributed busbar protection, which are both absolutely valid ways of doing distributed busbar protection with SIPROTEC 5, we have for both types the same communication topologies. Each communication topology I will explain now are applicable for both ways of distributed busbar protection. Of course, if I see here for the first, here this HSR up to 48 measuring points is 48 measuring points will be only possible for the fully distributed busbar protection, but the same topology for the IEC compliant will be applicable for up to 24 measuring points. So that's the only exception. Let's come now really to the different communication topologies. I will start with the, from my point of view, most cost-effective, from my point of view, the best way to make a distributed busbar protection at the moment. It's HSR, it's high Siemens redundancy, and here in the maximum configuration we have 3 HSR ring. So we have 1 HSR ring will be sufficient for a configuration with up to 16 bays. It's more precise to say not up to 16 bays, it's up to 16 current measuring points. So for up to 16 current measuring points, we need 1 HSR ring. That means each Ethernet PD module in the 7SS85 can be used with up to 16 current measuring points. If I need a bigger topology, For beginning from 70 to 31, I need a third HSR ring with a second, with a second Ethernet PD module here. And for very big configuration, 32 to 48, we need a third PD module for the bay units 32 to 48. SIPROTEC 5 have up to 4 communication slots available. So even in the biggest communication, in the biggest configuration for 48, we will have 1 communication module left to make a substation communication. Let's come to the synchronization of the standard measured value. You know, it's a differential protection. And the main algorithm, as you have learned in our second tutorial, are the spontaneous algorithm. The algorithm based on really momentary values. And to make such a distributed busbar protection, such a differential protection, the standard measured values, the momentary values must be on a very high level be synchronized. And the way to do this is, we have some other ways. We can do it also via PTP, but that's higher hardware effort. I would not recommend. Really, the 95% the way we should do this is IEEE 1588. And to do a sample synchronization with IEEE 1588, we need every time a so-called grand master clock. And since version 9.40, since version 9.30, we have an integrated grand master clock available in our SIPROTEC 5 device. Or to be more precise, this integrated grand master clock is available at the Ethernet PD module. And here in this solution, we enable the integrated grand master clock in the PD module to make the sample synchronization. This integrated grand master clock is at the moment, and it will be the case, I guess, for at least 1 year, and free running grand master clock. And this means this grand master clock has no synchronization with a global time network like GBS, RQA, or anything else. This means on the other side, we can do only the sample synchronization for the distributed busbar protection. We cannot do a synchronization of date and time in the central unit and also not in the bay units. So we can't do in this configuration a date and time synchronization of the connected devices. But the good news is this is absolutely not necessary for distributed busbar protection. So the distributed busbar protection will run without any limits, also with this free running grand master clock. You don't need it. You also don't need it to make any synchronization of the fault records and anything, because in case of a fault, all necessary information to analyze the fault will be directly located in the 7SS85. So there's really absolutely no limit according distributed busbar protection, according differential protection with this free running grand master clock. Okay. So this first communication topology, I explain a little bit more in detail because a lot of stuff will be the same in the next communication topologies. So just in way, it's absolutely the same configuration as before, but I explained you at the end that no date and time synchronization of the 7SS85 and the bay units is possible. And so typically this date and time synchronization will be done via NTP or SNTV, which will be connected via the station bus. So it's quite easy. You will create an HSR ring from the station, from the substation communication, and you will do your date and time synchronization via SNTP or NTP. the rest. And for the station bus is also absolutely fine not to use a BT module, which is possible, of course, also, but costs a little bit more money. A BB module will be also sufficient to do this substation communication. A way to combine the HSR communication topology with a date and time communication is to not to activate the integrated grandmaster clock, which at the moment has no possibility to connect to a global time network, but we can use, for example, and Ratchet-COM 2488 as a grandmaster clock here. So this is an Ethernet switch, which can be used also as a pure grandmaster clock. And this grandmaster clock can be connected with a GPS antenna. And if the grandmaster clock is connected with a GPS antenna, we can do both the sampled measured value synchronization, as already explained, for the distributed busbar protection. And we can use in the same way the date and time synchronization in all connected devices. It's a little bit hardware effort. You need this Ratchet-COM. You use this Ratchet-COM and configure them as a grandmaster clock. And you are using 3 outputs to send this PDB signal to the 3 HSR rings. And then via a red box, you have to insert this PDB signal in each separate ring. So same communication topology, but we are using a grandmaster clock synchronized with a global time network like GPS, and we insert in each HSR ring this PDB signal. If we have only one HSR ring for smaller configuration, but at least it's possible for up to 16 base, for up to 16 current transformers. So I would say a lot of at least 60% of the substation can live also with this solution, and you want to have this date and time synchronization. So we can use a more cost-effective solution. We are using an OSA, the OSA 5401 SFP as a grandmaster clock. And this OSA SFP can also directly connect it to a GPS antenna. And then we insert directly this OSA SFP into the redbox RSG 909R to insert here really this PDB signal from the OSA SFP in the HSR ring. This was the next possibility. So this were the most common communication topologies and layouts for the HSR communication topology. So HSR, which offers us a redundancy. So the HSR ring, maybe just before the HSR ring, maybe to explain this also, can be interrupted at any place. It can be interrupted here or interrupted here without any loss of any signals from any bay units, because we have communications in both directions. And if you interrupt the ring at one location, you will not lose any communication to any of the devices. If you say, okay, we had lived for more than 20 years with old conventional busbar protection like the 752, and we had there also no redundancy of the communication. It's fine for me to live in the same way. Or we have still the communication infrastructure, the cable channels. We want to reuse it from the old 7SS52 or from any other old distributed busbar protection where have been used this star topology. Then you can still use this, and this configuration will not be discontinued or anyways. This communication topology will be alive since the lifetime of the distributed bus protection 7SS85. So then you can use the star layout, so the line mode. And here in this configuration, it's possible for up to 43 bay units. This limitations comes from the special limitation here of the number of the boards of the switches. We use one RADGETCOM 2488. In this RADGETCOM 2488, we are activating once again the Grandmaster clock. And you have the possibility, it's of course also if you have an external Grandmaster clock or a Grandmaster clock in the RADGETCOM switch, it's an option to connect this Grandmaster clock to a global time network like GPS or anything else. If it is connected to a GPS antenna, you can do once again both the sampled measured value synchronization and the date and time synchronization. If it's not connected to the GPS antenna, you can do once again only the sampled measured value synchronization, which is absolutely sufficient for the distributed busbar protection. To have more numbers of slots available, we extend this layout with an RST2288. This RST2288 has not the option of a Grandmaster clock and therefore is also a little bit cheaper. Each in the maximum configuration, each Ethernet PD module, it's once again, each PD module you can cover up to 16 current transformers. So for 43 bay units, we need 3 PD modules. Each of these 3 PD modules must be connected to the switch. And of course, also each bay unit must be connected to one slot in the switch. Important in this configuration is that here we have a mix of the different standard measured values which should be covered by a different Ethernet PD modules. In the HSR rings, if you remember, we have already a clear physically separation of the different PD modules. Each PD module has been covered and physically separated ring, and therefore no mix of the different information was possible. Here at the switches, we would have a mix, and it could be possible that also, let's assume here Ethernet PD module 1 should cover bay 1 to bay 16 and so on. And really to ensure that we have a clear separation, that only standard measured values from in the maximum 16 will receive the dedicated PD modules, we need an VLAN configuration to avoid an overload here of these Ethernet PD modules, which are designed, they are 100 megabit communication modules, they are designed for a maximum of 16 transformers. This VLAN configuration is really described in detail and very good in the application note 88. Also, a possibility of an star layout compared like the 7SS52. We can use for the RST2288 without a Grandmaster clock, and we can activate the Grandmaster clock once again in the Ethernet PD module. Once again, of course, clear, integrated Grandmaster clock, no connection to the GPS signal is possible. So it's not possible to make here the date and time synchronization via IEEE 1588. Also, a quite good solution, a little bit more hardware effort, but here we can reach really 48 bay units. We can use an Ethernet PD module, and each Ethernet PD module is directly connected and exclusively connected to one switch. And this one switch will cover up to 16 bay units. And here in the maximum configuration of the distributed busbar protection, we will have 48 bay units here. And the advantage here is that we don't need a VLAN configuration because we have, again, a physically separation of the different Ethernet BT modules. Okay, let's come to PRB. Here, PRB configuration for up to 22 bay units. It's PRB. We have LAN A, we have LAN B. We have a separate switch for each LAN. Here is a switch for that's a switch for LAN A, that's a switch for LAN B, and also each Ethernet BT module must be connected to each LAN, must be connected to switch 1 and to switch 2. To have really a full PRB redundancy according IEC 61850. So normally there are also 2 grandmaster clocks applied. And here in the solution, we are using 2 grandmaster clocks. We are using 2 times the solution I have already explained 2 slides before. We are using an OSA SFP as a grandmaster clock, insert them in a red box from an RSG 909R, and so the PTP signal of each grandmaster clock will be connected to each LAN separately. And here once again the same. And which grandmaster clock will be used will be handled out by the so-called best master clock algorithm. Another possibility to save a little bit money, but with I forget to mention here that for PRB configuration with external grandmaster clocks, the GPS antenna is no longer an option. Really, to make here really a parallel redundant protocol, the 2 independent grandmaster clocks must be synchronized by the same time source. So that in case if we lose one of these grandmaster clocks, in case we lose one of the LANs, the switching will be possible without any loss of any time. So here in this PRB configuration, the connection to a global time network is mandatory. A little bit of exception, because here we have internal mechanisms. If we want to use a PRB configuration, here layout for up to 24 bay units, we can also use the integrated grandmaster clock without a connection to GPS, because here the synchronization of these 2 grandmaster clocks will be handled by an internal mechanism. And the rest is the same. We have 2 RST switches, one for LAN A, the second for LAN B, and both all BT modules must be connected to both LANs. And once again, of course, no date and time synchronization via IEEE 1588 is possible. Okay, we come. Now I'm finished with the communication topologies. And now I have a question to the audience. Which communication topology will you use for your future distributed busbar protection systems? Is it fine for you, as in the past, to have no redundancy, like the star communication? Will you go for PRB communication? Will you go for HSR communication? Or you haven't decided yet? Maybe you want to have more information. Maybe you will contact me for further informations. So that's the question. And now I do not know what's planned. The results after the break. Okay. So Are there already some results get? Okay, so maybe we will start with a break, and after the break we will okay, maybe I will make the recap of the SIPROTEC 5 online configurator. So sorry, I was a little bit confused. So maybe it's a good idea to make the recap of the SIPROTEC 5 online configurator, and afterwards we will answer the poll. So sorry for the confusion. Okay, before the results of the pollution and before Nina, after the break, will show the configuration of a distributed busbar protection, just a small recap of the SIPROTEC 5 online configuration. What kind of substation Nina will configure, and what kind of devices, what kind of configuration I will select via the SIPROTEC 5 online configurator. It will be a double busbar with, with 4 feeders and with 1 coupler with 2 CDs. We have to configure several devices. We have to configure the cell unit 7SS85, the SIPROTEC 5 7SS85 needs 2 bus zones, and it needs a disconnector image. When do we need a disconnector image? We every time need a disconnector image if at least in 1 feeder we can assign a current transformer, a current information by the positions of disconnectors to different bus zones. And here, this current transformer can be either assigned to bus zone 1 or can be assigned to bus zone 2. So we need a disconnector image. As we want to configure a fully distributed busbar protection, we need a significant feature of a 7SS85 CU with 6 zones is sufficient, and inclusive the disconnector image. We need bay units, we need merging units. We will use, Nina will use later, dedicated bay units, the 6MU85. We need this 4 times. We need 4 feeders, and we need 1 coupler with 2 CDs. So we will configure 4 6MU85 with 1 CD and 1 6MU85 with 2 CDs. And the requirements according the binary inputs, binary outputs, LEDs, we have also discussed in detail in our first tutorial. We need in the minimum 8 per feeder bay and 7 per coupler bay, because in the coupler bay we will not have an advanced circuit breaker failure protection and circuit breaker failure protection, which could be started from an external device. And functions, we want to have the breaker failure protection in each bay unit, and end-fault protection, and we need a bus coupler differential protection. This bus coupler differential protection will be needed in the 7SS85. So now I'm aligned. Let's change to the configurator. I will activate the full mode. Okay, I will start. So I have now opened the SIPROTEC 5 configurator. You can find them simply via Google search, insert simply SIPROTEC 5 configurator, and you will find this very nice tool. Here you can enter directly an already known product code, and you can have a look what details are included in this product code. But I will configure a new device. I click to device. I say SIPROTEC 5. And I will select the busbar protection. So here are some words about busbar protection, but you should know in the meantime quite more than what is written here. I will say directly next. And now, very important, I think that's the most important step in configuring a busbar protection, is to select the correct type of 7SS85. So this type is a significant feature. That is what exactly I have explained. At the very beginning, you have the types of the centralized busbar protection or of the IEC 650 compliant distributed busbar protection. And here, don't forget to scroll down. There are more types available than you see originally. Here, all types which are starting with CU double point are the fully distributed busbar protection. So we have 6 zones, 20 zones, and as already said, sufficient for our configuration, sufficient for the example Nina will explain after the break. We will select 6 zones inclusive disconnector image. Fine. Here once again the information set with an 7SS85 CU. It's allowed, but it makes no sense. It's not possible to use any current or voltage terminals in a 7SS85 CU. Says for distributed busbar protection for 7SS85 CU, we have only one standard variant. It's the standard variant 4 with 19 binary inputs, 11 binary outputs, and no analog inputs. So we can see it here. Just have a look to the plug-in modules, and you will see that you have already one Ethernet PD module available, which is sufficient for our small example. And for a substation communication, I will add an Ethernet PD module. So the housing, it's flush mounting, it's a small display by default, I would say. For a sender unit of a busbar protection, a large display is a better option to see at least some single line feeders in the display page. Key switch, no, that's fine so far. Current version, we will use the current version. Let's have a look to the function point calculator. So first, the functions free of charge. So you will see that the process bus client is already included. So that's the basic functionality we will need to be the sender unit of a distributed busbar protection. So it's all fine. And as already said, this is the only SIPROTEC 5 device where this integrated master clock functionality is already free of charge. In all other devices, if you remember, I forgot to mention it, where we have used the grandmaster clock both in the 7SS85 and to have a redundancy of the grandmaster clock, we use the grandmaster clock also in one of the merging units, in the first merging unit. And for the grandmaster clock functionality in the merging unit, you have to pay some function points. Here in the 7SS85, it's free of charge. Let's go to the functions with coast. You will see there are not so many functions in difference to the distributed busbar protection, where we have a lot of functions with coast, the base, the circuit breaker, failure protection. For the 7SS85 CU, it's not so much. It's mainly for cybersecurity functionality and slow scan. And for busbar protection, we have the cross stabilization possible, and it could be the bus coupler differential protection also. And Nina said me he liked to also to present a bus coupler differential protection. So I will instantiate one bus coupler differential protection. Maybe one additional information at the site. This because I get a lot of requests. I have a coupler with UCDs. I want to operate this coupler in the well-known overlapping mode like the 7SS52. For the standard functionality of overlapping, you don't need any function points. This bus coupler differential protection, we explained it. in the last, or I guess it was in the second tutorial, is really a very special configuration only for couplers with DUCDs with a selective dripping. And only for this really selective dripping, where the zone between the two CDs will be handled like a separate zone. Only therefore you need these 50 function points, not for the standard coupler in the overlapping mode. So that's very important because I get a lot of requests according to this question every time. So I will apply. Open 15 function points, and I would say this could be fine. I will finish. Okay, now we have the product code for the 7SS85CU, and Nina is already writing down the product code later to use this product code in DIGSI 5 for her demonstration of the distributed busbar protection configuration. But we need also some bay units. We selecting a merging unit / bay unit. It's fine. Let's go next. We don't need a redundant power supply for our demonstration. We will start with the standard variant HA1, as already said. With the standard variant HA1, you have quite the same functionality like in the small 7SS52 bay units, the 7SS525. So we will start with this standard variant. So we have 11 binary inputs. We have 9 binary outputs, 6 fast, so this will be absolutely fine. And we have 4 CDs for protection, so that's absolutely fine if you remember. What's still? Okay, we have 4. Let's go to the plug-in modules, and you will see here we have already in the standard variant 1 800BD module, which is necessary for the communication for the distributed busbar protection. This will be fine for our example. Let's go next. We have a housing, flush mounting, no display. So by default for merging units, we have no display. But for the application to be a bay unit of a distributed busbar protection, I would say we should spend at least a small display. And let's go, most important, to the function points calculator. So functions free of charge, not so interesting. And here, very important, there is free of charge one IC 650-9-2 merging unit functionality standard. So with this merging unit functionality, this pure merging unit functionality, you can do without additional costs a distributed busbar protection IE650 compliant. To make a communication with a 7SS85CU, you need to apply this 95 function points for a merging unit functionality for the 7SS85CU. But don't think this is very expensive because on the other side you have sender units, 7SS85CU with lower costs. And very important, it's not necessary to buy by function points base in the sender unit. So in the end, the 7SS85CU solution and the IEC 650 compliance solution, it's quite absolutely the same money. So very important for a communication to a 7SS85CU, you have to base this 95 function points. So let's do We offer current protection. We are not interested. We need a circuit breaker failure protection. And we need the end-fault protection for the 7SS85CU. Of course, you will find the same entries, this merging unit functionality for the 7SS85CU and the end-fault protection for 7SS85CU in all modular SIPROTEC 5 devices. And there you can them also activate. Okay, circuit breaker, did I forget? End-fault protection, directional overall current protection, not so interesting. I would say this would be fine. I will apply it. Okay, should it be? Let's finish. Next product code, of course, that's a merging units, bay unit for our feeder base, and you need to buy them 4 times, of course. But we still need one further bay unit, a bay unit for the coupler with 2 CDs, and therefore I will configure one merging unit with 2 CDs. I will start once again. Okay, merging unit. And we have next. Once again, no redundant power supply. We will start once again with a HA1. Next. We have, it's the same standard variant. You will trust me, we will have already one Ethernet PD module available, but we need now 2 current transformer, and therefore I will simply add one additional IO201. So that's the IO201. I will add it. And I will say next. Let's go once again to the function point calculator, cost with function. So we have here once again the same build. We need once again the merging unit functionality for the SS85CU. And as I have several times announced, we are using now 2 CDs, but 1 times this 95 function points are completely sufficient, because with this one 7SS85CU merging unit stream, you can send up to 8 current measuring points to the 7SS85 central unit. So we don't need an overcurrent protection. We don't need a circuit breaker failure protection 3-pole, as we are in a coupler, and typically we have no additional protection device which will start the external circuit breaker failure protection on the 7SS85. But it's very important, especially also in combination with the busbar differential protection, to have an end-fault protection. And the end-fault protection I will activate here. Okay, that should it be. I say apply. Anything forgot? So let's finish. And now, Nina, your last device, which is missing to make your configuration. But now I am finished, and now will we have now first the questions or directly the poll?
I think we start with the questions, because we already have quite a few of them. And let's see, Nina, do you want to join us on stage, just in case
I
that
have done for the presentation. Nina now has to answer questions.
That was just the warm-up, I think, right? So let's see, we have a lot of questions, and yeah, we will enlarge there. Start with the oldest one first, and I think the first question is one that I'm going to answer, so relax for a while. AR wants to know, can I get the other videos of the previous webinars? And yes, that's exactly no problem. We have this general webinar page for the tutorial series. And if you're registered for one of the tutorials, you can automatically access all the other recordings there. So just go on the tutorial page, and I think I distributed the access to it at the chat, and it will also be distributed with this recording. And now that'll be a question to one of you. Kale wants to know, what is the difference between the process bus in fully distributed solution, so with only Siemens MUs, and the process bus of an IEC 61850 compliant solution? Are they not both compliant to IEC 61850-9-2?
Maybe I take this one for a start. Yes, both are compliant to the IEC 61850 standard. The difference is that for the 7SS85CU solution, there's a simplified engineering process, and the stream time is fixed to 4000 Hertz, 1 ASTU. And for the binary signals, there are some extensions.
All right. Thanks. And so we just go on the next one. VB is not clear if he or she got it. Can you please kind of repeat about the 7SS85CU, the types SF, FK with up to 48 bays? Is it possible, or is it not possible to connect non-SIPROTEC 5 IEDs as bay merging units?
Sure. Okay, yeah, I can take this as well.
A warm-up for the next run.
I am tired now.
No, you're not.
But now I will.
Yeah. Nina knows.
Yes,
Nina
sure,
knows.
I can take it. For the 7SS85CU solution, you can connect modular SIPROTEC 5 devices. And for the the IEC 61850 compliant.
Can you go back to the question?
I think it's hidden and answered.
Did I miss the point?
I was not. I think it was. Is it possible not to get non-SIPROTEC 5 IEDs? I think
okay.
This question you will answer also.
No, this is not possible. This would only be possible with this IEC 61850 compliant solution.
All right. Thanks. So, and would it be possible, so next question from Phoebe, would it be possible to use all 4 Ethernet modules for the distributed busbar protection?
No, I will answer.
Okay.
You have to concentrate also for your next for the next hour. No, it's not possible at the moment, and it will bring, or it would bring also at the moment, no additional benefits, because we will cover up to 48. That means 16 CTs per Ethernet BT module. That's 48. And the problem at the moment will be that now also the 7SS85CU will be at the limit of the memory. So with the 4th Ethernet module, it's not supported yet, but it would bring no benefit because we have here with 48 anyway problems with memory. And the solution, and we will not go, we will of course look for a solution to come up to 60 bay units. But it will be not the solution to support 4 Ethernet modules for process bus, because then you have no more communication slot for the substation communication. We are already working to replace the Ethernet BT module 100 megabit with a gigabit module, and with a gigabit module you will have 1 Ethernet module and you can cover up to 60 bay units. So that will be the future.
All right. So that already took kind of the next question, already an answer for that, because yes, we are planning to apply 1 gigabit Ethernet in the future.
I haven't
right?
seen this question, but I have already answered.
Already answered. So yeah, I'm not sure how I find that. So yes.
But thanks for selecting the next question in this way.
Perfect. So we can directly jump to the one from VB. Do you have any kind of special requirements for the distributed busbar protection based on an HSR ring network topology For example, the SM stream type should be a 4800 SMP with 2 ASDUs.
Do you want to answer?
Maybe
Still thinking on the complicated question, right?
I can say that for the 7SS85CU solution, the stream time is fixed on 4000 Hertz 1 ASDU. But honestly, for the IEC 61850 compliant solution, both is possible, I would say.
Yes, you are absolutely right. For the IEC 6150 compliant solution, where you can all IEC 6150 compliant stream types you can select, and here you can select each possible also for HSR. Maybe once again, this is why I do not use in my 7SS85CU, where it is fixed the solution with 2 ASDU. This is a little bit SIPROTEC 5 internal, because this 2 ASDU means that in one telegram, in one stream, we are sending both 2 succeeding sampled measured values. This means if you lose one telegram, you have already lost 2 succeeding sampled measured values. And this will lead to a short temporary blocking. And that's the reason why we used a stream type with only 1 ASDU, because this means if one telegram, if one stream is lost, this can be compensated by a linear approximation in the device, and therefore one lost telegram will not lose to a temporary blocking. And that's the reason why we, the development, and me as PLM, decided to go for 4000 Hertz and only 1 ASDU. And this is also absolutely sufficient, because I get this question quite a lot of time for 60 Hertz.
Okay.
There's no problem.
Thanks. All right. Next one is an applause for us. Thanks a lot. And there's a small demo setup where they use OSA 5401 SFP as the grandmaster clock. And even the IEDs of other vendors are receiving the time sync signal and are kind of locked to the same grandmaster. So that's kind of, yes, it works. Tested not only in our headquarters and our test and our presentation, but also tested out there. Thanks for the info. And now we take the question from MTI. For 16M News, so merging units, is it necessary to connect both BD module ports with the Ethernet switch? BD module.
Yeah, here's not the question. The 16 merging units, so 16 merging units or 16 CTs, to be more precise, is sufficient for one Ethernet BT module. Whether you have to connect both ports of the BT module depends on the protocol. For PRB, you have to connect each port to the different switches, to the different LANs. For HSR, you have with the 2 ports to close the loop. And for a simple star topology, line topology, it's sufficient to connect only 1 port. Okay. But it not depends on the 16 MUs. It depends on the communication protocol.
On the configuration there, right? Yeah. All right. Thank you. And then the next question came in from HC. In the case of a 7SS85 distributed busbar protection, how will be sent the trip information, so from the 7SS85 to the 6MU85? Will that be done with GOOS, or will it be the same bus configuration of the sample values?
For the 7SS85CU solution, the exchange of binary signal is not done via GOOS. And this is where this solution differs from this IEC 61850 compliant solution, because here we do have a little bit of proprietary protocol, I would say. But of course, it is possible to additionally activate GOOS if there are some individual signals are necessary.
All right, thanks.
Completely correct. It's of course correct, but once again, you know me, one additional, because he asked also, is it on the same bus? Of course, it will be independent whether you use GOOS in the IC compliant or with the 7SS85CU, the bus will be used the same. It will be every time the same Ethernet network where this signals will be transmitted. The bus will be every time the same. But as Nina has said one time, the so-called Busbar Protection Protocol for the binary signals, and in the IC compliant, it will be used. It will be good. So completely right.
Sorry. Already right? Just an addition. No. Perfect.
Nina's always right, but yes. I always make some extensions.
Yeah. That's true. Yeah, she knows a lot. That's why I love to have these two experts here, because then you get a really comprehensive answer. So let's continue with the next question. LR wants to know what is slow scan and what is continuous recorder. I think it was in the first half of an hour during your presentation that the question came in.
No, I hope for Nina, because to be honest, really the details about the slow scan and the continuous recorder, I am not prepared to give here an answer within 2 sentences.
Okay,
so it's maybe to explain, it's SIPROTEC 5 functionality, and some functionality will be added to each device. And as PLM, you may decide to make it sense for your device or not, and I can refuse. But I do not go into details for each SIPROTEC 5 functionality which is available. But it will be no problem for me or for Nina to ask the PLM to have some documentation, and we will answer these questions, of course, when we answer all unanswered.
So
we will write an answer for sure.
That answer will be part of your homework.
Yes.
Because
exactly.
This I did not yet share with you. The two experts will receive homework from us here in the studio. All the questions you type in, they will receive, and you will get additionally to this one a written answer. And if the question, or if the answer was not really what you expected, or if we misunderstood your questions, just contact the experts directly, please. So we take the last 2 questions before the break. So PG wants to know, could you elaborate on cross-stabilization? Oh, that's a complicated one.
I can do, but it's not so easy. There are chapters in the manual,
right.
But let me try to explain it in some sentences.
In 2 seconds?
No, 3.
Go ahead.
In switchgears, in 3-boot and encapsulated switchgears, there is a phenomenon. It's a problem of the GIS substation with 3-phase encapsulated. And here a very high external fault can inject in the secondary current of the current measurement and differential current, which would be interpreted like a differential current for the Busbar differential protection. And this could, and it happened in reality in the past, I guess it was 15 years ago, to a wrong tripping of the Busbar differential protection due to the phenomena. And this cross stabilization is a functionality to be safe against this phenomena.
Perfect. Sounds great. Thanks. So last question before the short break. Taylor wants to know, in PRP configuration with the RST2228 switches, so 2228 switches, do we use data filtering? And is this necessary to distribute the data flow from the merging units to the different ports? I think that's an on 7SS85.
I do not
exactly complicated question, I think, huh?
The PRP configuration with the RST228 switches. Yes, I remember. And data filtering, I do not exactly know what was data filtering. Maybe he asked whether there's also a VLAN configuration to make the separation. And did I forget to mention that this also in this configuration, like in the configuration before, a VLAN configuration is necessary. But I am not absolutely sure what this data filtering. Of course, we are doing a lot of filtering in our merging units and so on. There's in the whole chain of our measurement acquisitions, there's a lot of data filtering. but I am not very sure what exactly KL is asking for.
Okay, so let's put it this way, KL, please get into direct contact with the experts and elaborate a bit more on the question. It seems a short question.
But now he sits to the different boards. Can you go back?
No, somehow answered and hidden.
Yeah,
you
okay.
will see. You will see it in the list.
But on the last second, I said for the different boards, so it seems a little bit more. It was really like this VLAN configuration that this will be necessary in this case also.
Okay, so I think we take this in the into the homework, and there will be a question and answer. And if this is not sufficient, just get in contact again. So I think by now it's time for a short break. I guess we will do a bit less than, what's the time here? 15. So about 10 minutes might be a nice range to get for you, maybe to get a bit of fresh air. At least we here in the studio need to do so. Try to give your eyes a bit of a rest, because staring on the monitor is not the best. Close them for a while, do something else, and meet us again in a bit less than 10 minutes.
Maybe
and we will start a 5 minutes timer, so you will be able to check when we will be back to you again. So see you in a few minutes. Stay tuned.
Bye-bye.
All right, welcome back. I hope you enjoyed a short break. We in the studio here did, so that we will be kind of freshly full of energy just for you out there. And I think we had a poll question, and let's see a bit of the results, because then we share what you shared with us. We'd like to share back to you and with the experts here. So let's see, that's small up here. So you can stay there.
Okay.
I will read. It's, oh, perfect. Enlargement is possible also there. So about 20% have no redundancy in the star configuration in the system. PRP is used at 20.7. No, 27% of the configurations you shared with us. HSR is kind of the biggest portion of it. It's about a third, and then it's open. And there are still some changing values in there. So thanks a lot for sharing that information with you. And sharing is what Nina will now do with you. She will share her knowledge on how to configure a distributed busbar protection with a 7SS85CU in DIGSI 5. So open up ears and eyes, and Nina, let's go.
Thank you. All right. So this is the example we want to use for the demonstration in DIGSI 5. Rainer already explained it a little bit. We have a double busbar here with 4 line feeders and a coupler with 2 CTs. And the steps we do when configuring the device are the following. So we create the first step, the single line diagram. We create, of course, the devices, the 7SS85, the 6MU85 typical, and the 6MU85 coupler. We will reconfigure the communication settings. We need, of course, to insert all the elements that we see here in this example, all the disconnectors, current transformers, circuit breakers. We insert in the depth the functions that we want to use. We will do the binary inputs and binary output routing in the information routing. And then we want to create the 6MU85 child devices for all the other feeders. And then we will do the connection to the single line. Then we update the CU-BU assignment, that everything is configured according to the topology. And as a last step, we will have a look at the system configurator and do the necessary configuration there. Okay, so much about the theory. Let's jump right in to DIGSI. So here I already did some things in preparation. I already created the devices with the product codes that Rainer configured. And I already created some of the elements of the single line, because here I already inserted the 2 bus bars and the drawing for our coupler bay with these 2 CTs. Okay, then let's start with the single line configurator. Here I do this, put this on full screen, or maybe this was a step too fast because I still need the library. I open this back again. And here I go in the library to single line and display elements and open this folder here. And here we offer some templates to make the engineering process for you a little bit faster and easier. And for our example, I want to use the template. Let me check the double busbar line feeder template. I insert this to the single line by simply drag and drop. And here are already some bus bars included. Of course, we don't need 3 and 4 bus bars. I delete this one and arrange it a little bit nicely. And here you can see in this template, there are some elements that we don't use in our example. There is a second current transformer, there's a voltage transformer, and a line disconnector. In our example, we have those elements don't use these elements, there are two possibilities. Either you just leave them like it is in this example. This really do not harm the configuration, because only those elements that are connected to the elements in the devices are part of our busbar protection system. So you can leave them, you can delete them. I will delete some of them and leave one in, that you can see how this is working, how they are disappearing in the filtered view, I would say. So in our case, I delete the second current transformer, I delete the voltage transformer, and just leave the line disconnector in to show you how this will look like later on. Of course, then I have to reconnect again and maybe arrange the elements a little bit nicely so that everything, is good, to have a good overview. And then, of course, I have to connect the bay to the bus bars. So in this case, I connect the left disconnector to the upper bus bar and the right one to the lower bus bar. And here you see the names are still not very meaningful. As a first step, I will call the coupler bay as it is. And the bay 2, I will rename to bay 1. And this bay 1, we do not only need this one time, but 4 times. So I simply copy this bay and insert it 3 more times. So the second bay here on the left side of the coupler, and maybe I have to copy it again. And on the right side of the coupler, bay 3 and bay 4. Okay, then I have to do, of course, for the other bays also the connection to the bus bars in the same way as before. The left disconnector goes to the upper bus bar, the right one to the lower bus bar. Okay, now we have almost the same single line configuration as shown in the slides, with the small difference that these elements of the line disconnectors are still there. Okay, so much about the single line diagram. As a next step, I want to start configuring the 7SS85CU device. So I open my project tree again and navigate here to my 7SS85CU device. And here's the first step. I open the device information. And here you can see the first name is the device, how it is called in the project. And the second device, the second name is the IEC 61850 name. And this is relevant if you do some connections in the system configurator. And here it is really helpful to give the devices a meaningful name, that you have the chance to do the correct connections right and to have a good overview in the system configurator. The default name is just SAP. I rename it here to SS85 CU, for example. Maybe use big letters. Okay. And as a next step, I want to go to the communication settings for the 7SS85CU. Therefore, I open hardware and protocols and double click on the Ethernet BD module. This is the one on the bottom here. And then in this property field on the bottom of the software are the settings for this Ethernet BD module. And I start here under protocols and communication with selecting the 9-2 client 7SS85CU protocol. This is really this 7SS85CU protocol, as explained earlier, has some advantages in case for an easier engineering in DIGSI. It has some extensions for the binary signal exchange between bay units and merging units, bay units and central units. and it have this fixed stream type. Okay, now we can see here this checkbox is activated, so this setting is made. As the next step, I go to redundancy. And here you can see the default value is line mode, so no redundancy. In our example, I want to demonstrate the HSR communication topology. So I change it here to HSR. And yes, I confirm that I want to change the protocol selection. Give it some seconds. Okay, here we go. And then under network, I need to activate the IEEE 1588. This is the sampled measured value synchronization. So this is no date and time synchronization. It is only for the sampled measured values, but it is fully sufficient for the 7SS85CU or for the busbar communication. So the checkbox is activated, so we are good to go. And under the settings, there are some settings for the 7SS85CU protocol. And here, I want to give you a hint about this accepted sampled value synchronization. The default value here is a 2, and 2 means you have a global time source or global grandmaster clock. And in our case, we do use the integrated grandmaster clock in the 7SS85CU. This is a local time source, and that's why I need to change the value from a 2 to a 1. Okay, save the project. It's always a good idea. And then we take a look at the IEEE 1588 settings. And these settings are relevant if you want to make some changes to the grandmaster clock settings. And here the default value is that this speed module has only a slave-only functionality. But in the 7SS85CU, we want to activate the grandmaster clock. So I activate this checkbox here, ordinary clock grandmaster capable. These other checkboxes will disappear automatically. Okay. And yeah, these are all the settings we need to do about the communication in the 7SS85CU. But there is, one more change we need to do, because if we go back to the single line configurator and navigate to our 7SS85CU device, we see that per default here in the function group busbar protection, there's only one bus zone. For our configuration, we need 2 bus zones. So as a next step, I want to insert the second zone. So I go on the right side to the library and navigate to our busbar protection, the second one. And under the function group busbar and in the folder busbar protection and function extensions, there is the option to insert another bus zone. So by simply drag and drop it, I can insert this here just right in the single line diagram. And now we can see we have here in the function group busbar protection these 2 bus zones. The connections to the single line we will do at the end when all the devices are configured. So this was all about the 7SS85 for the moment. Let's jump to the 6MU85Bay. This time I called this device 6MU85Bay X typical, because this is really the typical device that we want to use as a copy master, or as a typical bay, just call it like it is, as a typical bay for all the feeder bays. And here I want to demonstrate this new DIGSI feature, which is available since version 9.50, this typical bay engineering, where one device can act as a parent device to some child devices. and where all the settings of the parent device are then automatically can be applied to all the child devices. And this is really a nice feature for the busbar protection, and that's why I want to demonstrate it today. So let's make at first the settings for this typical bay, and then in the second step, I want to demonstrate you how to create these child devices. So here, once again, I start with the communication settings. So double click on hardware and protocols, double click to the Ethernet BD module. And here we start under protocols with communication by selecting this 9-2 merging unit 7SS85 CU protocol. Okay, checkbox is activated. Next step would be to change here also the setting according the redundancy. So I changed the default value from line mode here to HSR. And confirm this pop-up window. And then under network, we also need to activate the IEEE 1588 sampled measured value synchronization, of course, for all the merging units as well. Okay, and then let's have a look at the settings. Under the 9-2 merging unit, nothing needs to be changed. But yeah, let's take a look at the IEEE 1588 settings. Now we can see here in this case, these default settings slave only is the right one because the grandmaster clock is running in the 7SS85 and not in the merging unit. So we are finished with the communication settings here for the merging unit. And as a next step, I want to insert the necessary elements for our merging unit. So I go to the library on the right side again and navigate this time to our merging unit folder. And here under switching devices, the last folder in the row, there is this function group disconnector status only. And this is sufficient normally for a busbar configuration. And as you hopefully remember, we have 2 disconnectors in our configuration. So via drag and drop, I insert this function group disconnector 2 times. As we can see here in the project tree, a function group circuit breaker. And when I open the measuring points, the measuring point 3 phase are already available by default when using the 6MU basic template. So in this, at the moment we all have the necessary function groups, but we still don't have the necessary functions. And this is what I want to do now. So as you can see on the circuit breaker, there are, we want to insert now the circuit breaker failure protection and the end fault protection. So I go back to the library, open the function group circuit breaker, and go there down to the folder distributed busbar protection function extensions. And here you see the 50BF, the breaker failure protection inherent. This is the one that's get activated when there was an internal busbar fault. So I insert this via drag and drop to the function group circuit breaker. And I insert as well the end fault protection to the function group circuit breaker. And for the feeder base, we do not only want these inherent circuit breaker failure protection, but we also want the external or additional circuit breaker failure protection function, which can get activated when there was an external fault. For example, from the remote end, distance protection, line protection, whatever. So for this function, I go, of course, as well in the function group circuit breaker. And here under circuit breaker failure protection, there's this 50 BF additional circuit breaker failure protection function. So this one I insert also to the function group circuit breaker. And here I also want to make a small setting change to this 50 BF additional function block. So I open this one by double click. And here you can see by under these settings here, this value for start via binary input is per default set to no. And here I want to change it to one channel. So this is a setting where you can define, is it possible to activate this function via a binary input that is, for example, received from the remote end. Okay. So these are all the functions and settings that I want to change right now. So as a next step, I want to have a look at the routings that are typically done for the busbar protection. So I open the information routing. And here, maybe give this a little bit more space here. And yeah, we'll start with the circuit breaker settings. And here we can see under the function group circuit breaker and under circuit breaker, there are per default the inputs open high and closed high of the circuit breaker position per default connected to the sources binary input 1.1 and 1.2. So this is already fine for me. But now I want also to add the inputs for the 50EF and 50BF. So in this time I start with the N4 protection. And for those who watched our second tutorial, I think, I hope you remember that it makes always sense to connect these close signal from the N4 protection. So for those who didn't watch, maybe I can always recommend it to watch it on demand, because it would lead a little bit too far to explain it again here. And this time I will just route it with a high signal to 1.3. And for this additional 50 BF function, I want to route this or assign the start signal to binary input 1.4. So much about the circuit breaker. Now still missing are the positions of the disconnectors. So open here this function group disconnector, go to the position and assign them to input 1.5 and 1.6, open high and closed high with 2 channels in this case. Same for the second disconnector. This time binary input 1.7 and 1.6, open high and closed high. And then, of course, we do not only need binary inputs, but also binary outputs to transmit the trip signal to the circuit breaker. So I open again the circuit breaker here and go to circuit breaker again. And here you can see this trip open command. This is the one you should connect to your circuit breaker. And you can see here also under binary output that this signal is per default routed to the output 1.1. And this is fine for me. I just leave it like this. And this is all I want to do for our 6MU Bay typical for the moment. So the next step, I want to go to our 6MU85 for the coupler. And don't worry, I don't want to repeat everything again. I just want to mention what is different from the feeder bay to the coupler bay. And this coupler bay is the one with these 2 CTs in the coupler. And under measuring points, if you open this by double click, you can see per default there's only 1 measuring point 3-phase available. Here we need a second one. So I press this add new button, select the 3-phase measuring point, and then connect these input signals of this expansion module 3. Okay, and here you can see there's this red bubble coming up. Let's have a look under properties, what happened here. Under info or inconsistencies, you can always check if you see there is something wrong with your configuration, you can check what is wrong here. And you can see here on the 6MU coupler, there's now this information that this measuring point that I newly created is not connected to any function group. And here we do need a connection. And this is why I now, in the next step, I want to add a function group voltage current phase that, yeah, I can establish these missing connections here. Maybe you can say it is in this case only like a dummy function group. You don't need to put any functionality in it. It's just that this measuring point has a connection. But of course, if you want backup functionality, you can use this function group as well for this backup functionality. So I go here under 6MU85 to the function group voltage current phase and insert this to the settings of the merging unit also via drag and drop. And the connection between the measuring point and the function group can be done under function group connections. There's another matrix, and here is the needed assignment between the measuring point and the function group. Okay, so I saved this one. And let me check my notes if I missed something. I think the communication settings in this case I've already done in preparation. The disconnectors are also already inserted in this device, but there's one more thing I want to mention for this coupler bay. And therefore I go again to the circuit breaker function group and in the library also to the circuit breaker function group to insert the circuit breaker failure protection. And this time I only want to insert these 50BF inherent circuit breaker failure protection and not these additional circuit breaker failure protection. Because typically it makes, it's not so common that you would receive an external drip in the coupler bay. So I only insert here this inherent one to the function group circuit breaker. And of course the end fault protection as well. Okay, and these are all the changes that need to be done for the 6MU85 coupler. So as a next step, I want to demonstrate you how to do the engineering for this typical bay and how to create child devices. Therefore, I go to our 6MU85 typical. Under device information, there's now, since version 9.40, the option here, typical settings. And also here the information, if a device is made typical, the device will act as a parent to the subordinate instances created from it. And this is exactly what we want to do. We want to say now this 6MU for the feeder base is our typical device. So I activate this checkbox here. To process this information, all the editors need to be closed. This is no problem for me. And now you can see in the project tree, here are still my 7SS85 and my 6MU85 of the coupler. And now in this folder, now there's automatically created a folder called 6MU85 Bay X typical. And here is the device that we configured some minutes ago. And maybe you can have a look at some of the settings. For example, if we open here this circuit breaker function group, I don't know, the 50BF inherent function, you can see all the settings are gray now in this typical bay. And this means for the moment, these settings are locked. And to keep tuned, I want to explain later now how to change this. But as the next step, I want to demonstrate how to create the child devices from this parent typical device. And therefore, I go to our Bay typical, do a right mouse click, and select the option Add Child Devices. And we have 4 feeder bays, therefore I need 4 of these 6MU devices. And here you can already change the name of these devices, and I will rename them 6MU85 Bay 1 to Bay 4. And for the IEC name, I will use merging unit Bay 1 to 4. Copy this one to be a little bit faster. And confirm this was okay. And now in the background, he is creating the child devices to our typical Bay. Okay, here they are. And with these small symbols below this device, you can see these are child devices, and this is the typical device. And for the moment, they really have the exactly, or not for the moment, for all time, they have exactly the same settings as the parent device. But of course, it is possible if some settings are individual for a feeder bay, it is possible to change them and to lock them against changes. Even if I change something in the typical device, it is possible to lock the changes in one of the individual feeder bays if I don't want to apply this change to this specific child device. And this is done by this button, I would call this, with this very little lock symbol. You can just press this, and then this lock symbol is closed, and then this setting is not changed even if I make a change later on in the parent device. Okay, so I've saved the settings for the moment, and yeah, this is all necessary steps that needs to be done for the configuration of the devices. So as a next step, I want to do the connections between the single line diagram and our devices. So I go to the single line diagram once again and do this to full screen. Okay, so now we can see here are all the devices that were newly created. Now I will arrange them real quick that we have a better overview. So Bay 6MU85 Bay 4 to Bay 4, 3 to 3, and so on. And this Bay typical needs not to be connected. We can put this just on the bottom of this configurator. Okay, now I start with the first Bay. And here I start with the function group circuit breaker, and I connect the measuring point of the circuit breaker to its element in the single line configurator. And not only the measuring point, but also the position of the circuit breaker needs to be connected to this position symbol in the single line editor. Same for the disconnectors. Here Disconnector 1 is connected to the symbol of disconnector 1 in the single line, and disconnector 2 to disconnector 2 as well. And here as example, we won't connect this line disconnector, and later you will see in the filtered view that if an element here is not connected to any bay unit, then it is not relevant for our 7SS85 busbar protection system. And this is why this element is later on in the filtered view not even displayed. And this also helps you to double check if all the configuration of all the connections are done the right way. Because if you see, oh, there one element is not visible, then you maybe made an error and didn't connect it. Okay, same for all the other 4 bays without less talking. So measuring point to measuring point, position to position, and the disconnectors to the disconnectors. For the coupler bay with the 2 CTs, typically you connect the measuring point of the circuit breaker to this current transformer, which is the relevant one for the circuit breaker failure protection. But it is possible to connect it to both of them. So there are no default or recommendation to connect this one. So disconnector to disconnector. And here is our like dummy function group. Here I also connect this measuring point of this function group to the measuring point or to the current transformer element in the single line configurator. Bay 3 and 4 are of course the same as bay 1 and 2. And also not important to miss, the 7SS85CU. Here the 2 bus zones needs to be connected to these bus zones. Yeah, we have all the devices, we have done the connections. So as a next step, I want to refresh the CU-BU assignment. Yeah, what is meant with this? Well, at first, maybe there are 2 possible options to do this CU-BU assignment. First one is you go to the CU-BU assignment tab and use this update configuration button, or you go to the single line and change this view from all devices to 7SS85CU. And then there comes this pop-up window. Do you want to update the central unit bay unit assignment? Or it says that it is not updated. And yes, I want to update it now. And of course, this leads a little bit time, but here really all the connections between the bay units and merging units are made according to the single line diagram that we draw. So for all the elements in the bay units, for every circuit breaker, for the disconnectors, for the current transformers, some proxy elements are created in the 7SS85 with all the necessary information that you need later on and all the necessary signals that then later are connected in the system configurator. These are really created automatically according to the topology. And this is really one of the great benefits from the 7SS85CU solution, that this here is done automatically according to the topology. Okay, let's take a quick look what happened in the project tree on the left side. So for example, let's open the 7SS85CU and the settings here. And here we see now for each bay, feeder bay and the coupler bay, there's now this proxy element function group. We open it, for example, and here are the two disconnectors, the two current transformers, and the circuit breaker. And for example, from the circuit breaker, there are also here visible the 50BF and the 50EF function group that we inserted to the 6MU85 of the coupler. For example, if I open the information routing, here, of course, you see as well these proxy elements. And for example, if we open bay 1 and here the current transformer and, for example, the 50BF advanced, you can see these are all the elements that will be automatically transmitted between the bay unit and the merging unit without any engineering effort. And so here you can check what is already there by default. And as mentioned earlier in the Q&A session, if you miss a signal here, it is of course possible to additionally transmit these information via Goose. Okay, so one little thing must be done before we go to the system configurator, because we have here this coupler with the two CTs. And for this 2CT coupler, I want to demonstrate how to activate the bus coupler differential protection. This is a function running in the function group bay. And since this function group bay is created only after the CUBU assignment, this is the step we will do now. So I go on the right side in the library to the Busbar Protection folder and go here to the function group bay and down there to function extensions. And now here there's this coupler zone. And this I will drag and drop to our function group coupler. Here it is. And if we open the tab General from the coupler, here's the setting. If I want to arrange the CTs of the coupler in overlapping mode, yes or no. The default value is yes, but since we now add the coupler zone and we choose to have this selective tripping for our 2CT coupler, I change this value now from yes to no. If you missed this point, don't worry, DIGSI will remind you at least at the end when you do a consistency check, because you can leave this parameter to yes and have a coupler zone. So, I see on my notes there was one small thing I forget. I want to have a look at the filtered view again. And now I get the message that the filtered view was changed. So I will just update again the CUBU assignment, and then everything should be fine. Okay. Not yet. But let's check if there are some inconsistencies still. Okay, these are just the normal messages that are there because we did not yet do the configuration, the system configuration. So for the moment, we just leave it like that and hope all these warnings down there will go away if we do take a look at the system configurator. So one more thing to mention here. We can see now in this bay, there are not visible these line disconnectors that are visible in the other view. And this is exactly what I meant earlier. Only those elements are visible that are connected to a bay unit. And in this filtered view, this is also the view that you see in the online view. If you connect to your device with DIGSI, or if you connect to the device and open the web browser, this is what you see if you open the single line. So it makes always sense to arrange these measurement boxes a little bit nicely. So put everything to each bay where it belongs. And a coupler to coupler. Okay, and then we save this. And now as a next step, I want to create an IEC 61850 station. Therefore, I go under the folder in the project tree to IEC 61850 stations, double click on Add New Station, and then I double click on this newly created station to make some settings here. Here you can see these are the list of the available devices. Here, of course, are only those devices visible which have the same IEC 61850 version, 2.1 in our case. Now, all the devices are relevant for our communication configuration. So with this double arrow, I assign all these devices to the station. And then I press these export changes to the system configurator button, the one with the green arrow in the right direction. And then he will export it to the system configurator, and the system configurator will open automatically in the background. So now I get a warning that there's not yet IEC 61850 SCD file available. So yes, I want to create a new one, and then I have to say the system where to save it. So let me just search the right direction real quick. Okay, and then it's exporting everything that we've done just right now to the system configurator. Yeah, here we are. We see action completed, 0 faults, but 6 warnings. Let's have a look at them. And therefore I go to network and to the default subnet that was created. And here we see the root cause of this warning. And here you see at the moment, all the devices have the same IP address. It's not that this is a problem for the busbar protection. It will run anyway. But of course, we don't want any warnings here. So in this for this example, I just use this option, right mouse click, automatic addressing, and override all the existing IP addresses, and then they have individual IP addresses. And then I go to sampled measured values. Here is the station that was created by default with the 5 devices that are in our project. And with right mouse click to the station, there is the option sampled measured value mapping through topology. I click this one, and this goes really quick. And here, all the necessary connections between the merging unit and the bay units are really done automatically. So, for example, if we open the one for the settings for the bay 1, click here on merging unit and open the description a little bit, then you can see these are the connections from our sampled measured values here in the device merging unit bay 1 connected to 7SS85CU. Here's the connection of the sampled measured values. And as told earlier, the binary signal transmission between central unit and bay unit is not done via GOOS. So here's not a possibility to see them under GOOS, of course. There's no possibility to check these interconnections between merging unit and bay unit in the system configurator for the binary signals. But you can really trust the system here that these connections are done correctly anyway. And this is really the great benefit of the 7SS85CU technology, that there can't happen any faults because the connections are done automatically. So make sure that you save the changes in the system configurator, and then you can simply close the window. And then I will re-import these changes that are made in the system configurator to our DIGSI project. So here I press the button with the arrow in the left direction to re-import all these changes. Okay, I only see the green symbols, so this is fine. And luckily also our red bubbles disappeared, so hopefully everything went well. Now let's take a quick look what happened when importing all the settings from the system configurator. And therefore I go to the 7SS85CU and open, for example, the measuring point routing. Now you can see all these currents are received via process bus. So this was done automatically. And for example, if we go in the information routing, again, okay, I guess I already showed you that, that here are now these signals visible also from the bay units. Yeah, maybe let's take also a look to one of the merging units here and go to the merging unit routing. And this is the stream that is transmitted from the merging unit to the central unit. Maybe I click on this one and go to the properties of this stream. And maybe go to the settings down here. And here you can see these. Here it is this fixed stream time 4000 Hertz 1 ASDU. And you can also see the sampled measured value ID of this stream from Bay Unit 1. And for example, if you want to do use this stream, also connect the stream to another device of your process bus setup, it is also possible. So you can use this stream as well for another process bus communication. And this proves also that we are here really compatible to the IEC 61850 standard. Okay, then I would say as a last step, I want to demonstrate you how to make a change in the typical device. So let's assume here now everything is finished. You go to your station and do the factory acceptance test, for example, and you really realize, oh, I must change a parameter, for example, for the circuit breaker failure protection. Then how is this done? And therefore, I go to our typical device that is here down in the project tree in our typical folder. And as a first step, I hope you remember at the moment, all the settings are gray and it is not possible to change something at the moment. I'll show you real quick again. So here everything is gray, nothing can be changed. So as a first step, I go to device information in our typical and tell him now that I want to modify this version. So I press this modify option. all the editors needs to be closed again. And then he's creating a new typical device version V2. And this is the one in which we are doing the changes now. And this has the benefit that you always have the history of changes. So you still have the version V1, and the changes are made now in the version V2. So I told you I want to change something in the circuit breaker failure protection. So I simply go there and, for example, change the threshold value of the phase currents from 0.5 to 0.7, just as example. I save this. And of course, here you can do a lot more changes. I will leave it with this one small change for a demonstration. And now I go back to device information. And now I have to tell him that I'm finished by changing the version V2, and I want to apply these changes. So I use this button here. Close the editors again. And now, for example, if we go back to the settings, now everything is gray again and cannot be longer changed. So here we are kind of locked now. And now, of course, I have to apply these changes as well to the child devices. And this is done by this typical management option here. I open this by double click. And here you can see in this folder 6MU85 typical, there's a list of all these 4 child devices of our typical merging unit. And by activating the checkboxes here, I tell him that I want to apply the changes of the V2 versions to our child devices. Of course, if for some reason you want not apply the changes of for one specific bay unit, then you can simply not activate the checkbox for this bay unit where you don't want to do the change. In our case, I apply this change to all devices. Now I press the Update Child Devices button. Here, the pop-up window if I'm really sure. Yes, I am. And yeah, now in the background, he applies the change to all the merging units, to all the child devices. And of course, if you have done a lot of changes, this process can save you some time. And even more important, it is really fault-prone. So here it is no longer possible to forget one of the merging units, for example, because these changes are applied to all the child devices automatically. Okay, here we are. Here there's also a log file created and no warnings or errors did appear, so everything went well. Just confirm this with yes. And here you can see with this info symbol that the IC station is no longer up to date. I guess this was because by overwriting the settings of the child devices by the settings of our bay typical, I changed the IP addresses again, and of course this would affect the station. But if you see this symbol here for the IC61850 station, you just simply do the round trip. With round trip, this meant to export the changes to the system configurator, for example, with right mouse click here, export changes to system configurator, and after save the settings in the system configurator and closing it again, you re-import the changes by using here these import changes from system configurator button. And then everything should be fine again. Yeah, this was all I want to demonstrate in DIGSI today. Before the break, we have the chance to answer some more questions. So yeah, Michaela and Rainer, welcome back on stage.
And we do have questions
Du darfst wieder
out
muten.
there.
Nee, das sieht komisch aus.
Looks funny.
You're way
really.
too tall to be hidden somewhere. So
Okay.
let's keep it like this round. And I think we somehow need to get into another presentation mode. So
yeah.
it's DIGSI here, but it would be nice if we can get the presentation. There we go. Thanks a lot, so that people know where we are in this Q&A round. So talking about questions, one question I've seen quite a few times in the list there. Yes, you do get access to the presentation and to the recording and all of that. But now let's go to the more technical questions. KA wants to know, is it mandatory to use exactly rugged COM switches for PIP or the line connection?
A difficult question. It's not mandatory. You can normally use each Ethernet switch which applies all requirements we need, but it's quite complicated to make really all tests in detail. So we can say the rugged COM switch I have mentioned today are fully tested by our system test, and you can trust on their working. We are planning to do this during the coming years for at least one further Ethernet switch. But up to now, just to say, in principle, each switch can be used, but this switch is certified by us, and we certify and we prove you will have no problems, no faults.
Perfect. So not mandatory, but definitely recommended as it's already tested. And then KA wants to know, it was a bit earlier, what is an open topology? And I think this might even refer to the part before the break. But yeah, will be a question for later to get it back in context. So is the 6MU85 coupler a special type of merging unit?
No, it is not. In this case, we have a separate product code for this coupler merging unit, because I wanted to demonstrate this bus coupler, how to configure this bus coupler differential protection with 2 CTs. But of course, for example, if you only have one current transformer, you could have used exactly the same product code as for the feeder base. And there was also a small difference in the product code, because in the coupler bay, we didn't use this additional circuit breaker failure protection for the external trips. So we needed a little less function point for our coupler bay.
All right, thank you. The next question I can almost read, I think. Thank you. And it's a longer one. AK wants to know how to implement the blocking of output trip relays. So with all the functions BBP and BFP and OC should work normally. Just the output trip relays are blocked for all functions and not just for BBP. I think you can read the numbers there. One output should work for signalization that output trip relays are blocked. That looks like a really special configuration questions, and I'm not sure if you can answer it right here, or this will be part of your homework.
No, this will be part of my last presentation after the
Even
break.
better. So stay tuned. We will deliver an answer. And SH wants to know, if I have already some merging units added into the project, can I make one of those atypical and other as child devices without adding those from scratch?
Yes, of course, this can also be done for it already existing configuration.
So I can take one configuration and make it a typical. Cool.
Yes.
That's
But,
nice.
I guess one limitation, you have to upgrade it at least to to DIGSI 9.40, I guess.
It is necessary. It's necessary that you use DIGSI 9.40, but the configuration version of these devices must not be version 9.
But DIGSI, the precondition is DIGSI 9.40. Yes.
Okay, you need the special DIGSI version, but you can take the configuration you already did, right?
Yes.
Thanks a lot. And then RP wants to know, in the single line diagram, the CD star point is towards the line side. As per my understanding, it has to be towards the bus side as the protected object. So somebody wants a correction there, huh?
Definitely not. That's maybe a little bit of understanding from distance protection or anything else. In busbar protections, the CD star point must be like in the primary substation according to the direction of the grounding of the primary CD, and this can be in both directions. And also you have to think that's a special configuration. You have a coupler. In the coupler, you have the star point anyway in two directions coming from the two bus zones on the left and the right side. And you see here for one bus zone, it's in direction of the bus zone. For the other bus zone, it must be going away from this direction. So thinking about the special situation in the busbar protection, you can imagine it can't be so simple for busbar protection.
All right. Thanks a lot. And let's jump to the next question. HC wants to know, is it reasonable to imagine to use the station bus for the communication of the sampled value between 7SS85CU and the 6MU85 devices? Is it about cybersecurity or bus bandwidth? Or is it better to use a special bus only for that? So for the sampled value communication.
It's definitely better to use a special bus. So if you remember all my communication topologies, I have every time a separate communication slot for the station bus and a dedicated process bus for the distributed busbar protection. So I really have technically it would be possible, but the strong recommendation is to have a separate station bus and a separate process bus for the communication for the distributed busbar protection.
Is there a why you recommend that?
Yeah, because of the bandwidth. Via the station bus, you have no idea. There will be fault logs will be loaded, exhausting things, and you don't want to affect in any way really the protection.
Okay. So it's kind of a priority line, right?
Yes.
Okay. Yeah. Better take this way. All right. So, and then Vivi wants to know how to exclude the settings which shall not be modified in the child device. And I think you showed that with this little lock symbol, right?
Yes. So in the child devices beside in each setting, there's this small lock symbol. And if this lock is open, these settings can be overwritten by the typical base settings. And if this lock symbol is closed, then the setting is locked for the specific bay.
Then it's kind of protected against the change there. By the way, can I still change the information?
Yes.
Okay,
yes,
thanks.
Can.
And then SH wants to know, just like busbar protection, if we have a lot of merging units and line protection IDs, is it then recommended to build a single line diagram? And can the line ID be assigned to a line bay and relevant configuration to be initiated?
We have a lot of
I would say yes, you can draw all the elements that are physically there as well in the single line diagram. But to the busbar connection systems, you only connect those elements that are really relevant for the busbar connections.
For the busbar protection, yes, exactly.
Okay. Concentrate on the important information once again, right? All right. So last question before the break. KR wants to know, can we upload the configuration file to the merging unit from central units? And how can we monitor both central unit and merging units simultaneously on an HSR network without Ethernet switch?
You can do, or you can do this soon with a 9.50. There will be the so-called functionality of the routing manager available, and with this routing manager functionality, which will be released in the 9.50, I am waiting from day to day. Normally, it should have been released last week. I guess it will be released this week, and this functionality with the 9.50 will be available.
All right, thank you. So stay tuned, watch out for news around our configuration system.
The sales release has already been announced. In the sales release of the 9.50, you can already read this functionality has been released for sales. And
Perfect.
the delivery release is, we are waiting from day to day.
Okay, so, and we hope that you will wait for us, because in a few minutes we will continue this webinar. Once again, a short break for you, a short break for us here. I think about 7 or 8 minutes, something like this. We'll once again start the 5 minutes timer, so you will be there just on time when we restart. And Rainer will show you on the Busbar Protection maintenance and supervision functions. So stay tuned, see you in a few minutes. right, welcome back to this last portion of this last part of the tutorial webinars. I hope that you can still concentrate on what we deliver to you, what we share on information to you. And Rainer will now continue with this last part and share. Yeah, just come and join me on stage. Everything's fine. It's empty here. It's prepared for you because you will now learn on maintenance and supervision functions. So Rainer, please share your knowledge with us.
Oh, last run, last step.
Last man standing?
Okay. I don't hope so. Okay, maintenance and supervision functions. Let me start with a really very rough overview about the supervision function and the self-monitoring implemented, not only in the 7SS85 Busbar protection. That's mainly a general SIPROTEC 5 functionality, which we are using with some exceptions. Here, really a very rough overview. I will go more to the details later. Very important for Busbar protection. It's a general feature for SIPROTEC 5, but it's a supervision functionality which can be switched off in the 7SS85. That's a so-called fast current sum supervision, or ADC, analog digital converter supervision, which makes a plausibility check whether the sum of the three phase currents, E for phase 1, E for phase 2, E for phase 3, is nearly, of course, with some uncertainty, which is nearly equal to the neutral current. If this sum is not given with a certain uncertainty because of the uncertainty of this functionality, then we will immediately, and this means within 1 millisecond, block the busbar differential protection. And if you remember, our fast 1 out of 1 algorithm will trip within 1 millisecond. And that is the reason why in the 7SS85 and only in the 7SS85 this supervision functionality can't be switched off. We have implemented in our firmware basics, in general, a memory monitoring and a calculating of checksums in general. I think that's state of the art. This will be done in SIPROTEC 5 here, really by the basics of our firmware. We have also, of course, watchdogs for software monitoring. This will come later more in detail, we have implemented a triple control circuit supervision for the coil, and we have a triple circuit supervision also implemented. A little bit a repetition from mainly here the second tutorial when I explained the busbar differential algorithm. A measure to detect failures outside the protection itself. That's this monitoring of the differential current under normal load. You remember when I explained the busbar differential protection, this minimum differential current threshold, which should be higher than the load current of the feeder with the highest operational current, and the threshold of the differential current supervision. And this threshold should be lower than the operational current of the feeder with the lowest current. I hope you remember this was what I explained in the second tutorial, the most important settings for the busbar differential protection. And with these settings, it will be possible to detect CT faults, to detect wiring problems with the CTs, and you can also detect problems in the disconnector replica. Just a short repetition. If you want to have a deeper recap, simply watch to the video of our second tutorial. We have also in the second tutorial, Nina explained very in detail the supervision of the disconnector positions. only possible if you use pairs of auxiliary contacts. If you want to save some binary inputs, this supervision will not be possible. But today we have a distributed busbar protection, and then normally it should be no problem to have enough binary inputs really to detect the disconnector positions in pair of the auxiliary contacts to use both the normally closed and the normally high contact. Security against overfunction. So in general, in our SIPROTEC 5 hardware, we are using a 2-channel activation for all binary output types. That means both for the normal binary outputs and also for the type F binary outputs. So we have here the triple relay, and it can be activated only if the 2 channels will be activated. And this gives us a good safety against an overfunction of our binary outputs, not to give a trip command to a circuit breaker just by a hardware fault or anything else. We have a security against over and function and over and under function. I am sorry. And this is a cyclic testing, and this cyclic testing is implemented only for type F binary outputs. So we have once again our trip relay with a 2-channel activation, and cyclically we have a trip simulation of 1 channel separate. Here, first channel, second channel. And this, if you see here, of course, this is only a very rough schematic way to show it. Here we have these resistors, and this 1-channel activation will lead to a change in the voltage and the current, which can be measured, and then we can detect whether really our trip circuit is working correctly, is working as expected, and otherwise we would get a failure. And we would indicate it that we have a problem in our hardware by activating our outputs, our binary outputs. We have a zero crossing supervision. That is once again a supervision which can be switched off in the 7SS85. This supervision is especially necessary if one primary CT is a TB-Z current transformer. With a TB-Z current transformer, we have a very long tail of a DC offset, which is only a secondary current. And also, this problem is very high if we have different types with incoming and outgoing feeders. And this tail of secondary current, which is a DC offset, it's only in the secondary. It's not really a primary current which can be detected. You can only see it in the secondary current of the CD, and this can lead to a wrong tripping of our busbar differential protection. And therefore, we have this zero crossing supervision, which blocks temporarily the busbar differential protection to avoid a wrong tripping in case of such a tail of a secondary current. Maintenance functions. Here it's very important, once again, there are so many maintenance functions, pay off, pay out of service. And before using any of this maintenance function, really it should be clear what is the application of the different maintenance functions. When will we do a payout of service? A payout of service we will do if we have a primary CD, and this primary CD is shared between the busbar protection at one side and a feeder protection. Anyhow, it could be an overcurrent protection, a line differential protection, or any way. And this CD is shared. And we want to test, in this case, the feeder protection device, the line protection device, by injecting any current. If we have a bus side disconnector, it's no problem. We would open this all bus side disconnectors and we would have no assignment to the selective zones. If we would have an assigned line disconnectors, we would also not really need this bay out of service. But if we have no bus side disconnectors or it can't be opened on primary side, and we haven't connected the line disconnector to our busbar protection, then we need this bay out of service. If we activate the bay out of service, what will happen? The reaction is that all configured disconnectors are considered as open. And if we don't have a configured busbar disconnectors, which is possible in the 7SS85, you can directly connect a CD to a bus zone. Then, how to say, a virtual busbar disconnection would be opened. So no assignment to any selective zone would happen. The CD remains, but nevertheless, the CD remains in the checked zone. This is a security mechanism to avoid a wrong tripping in case you bring by fault the wrong bay into out of service and you will inject, and then you have nevertheless the risk of a busbar trip. And therefore, to be very safe, to have every time a double security, one fault should not lead to a wrong tripping of a busbar protection, and therefore the CD remains in the check zone. Additionally, the circuit breaker failure protection in the same bay will be blocked. And of course, the supervision of all disconnectors and the circuit breaker is also inactive. That's a bay out of service. You have a shared primary CD between busbar protection and line protection, and you want to test the line protection, the feeder protection, without affecting the busbar differential protection. Oh, I forgot one time, it was yesterday the same. I forgot to add the following thing. In the distributed busbar protection, what Nina has showed to us, we call the bay out of service measuring point out of service. In the central unit, in the bay of the 7SS85 serial, you have automatically available the signals, the binary inputs for the bay out of service functionality. In the bay units, as you can use every SIPROTEC 5 device, every modular SIPROTEC 5 device as a bay unit for the distributed busbar protection, you have to add this functionality from the library. You will find them under here merging unit, of course, also under 7SL 86 AB7, any modular device. It's every time the same structure. Here, the device name, measuring points. Here, current three-phase. And here you have this folder, distributed busbar protection function extension. And here you find this measuring point out of service. And you have to drag and drop them to the measuring point you want to bring out of service. Okay. Bay out of service. We have also, not since the very beginning, I guess it was since 8.80 or anything else, this functionality bay off, where you bring the mandatory mode of each element in SIPROTEC 5, and here it's the mode of the bay into the mode off. And what's the application here? The application here is really to prepare future bays in the configuration. Sometimes you have a substation, double busbar, 10 feeders, and you already know in 5 years it will not be 10 feeders, it will be 11, 12 feeders. But you want to finalize completely the check of the configuration. You want to make a factory acceptance test completely already with a 12 base. So you will do this. But the bays are not available yet. So you will complete your testing, including the 12 feeder bays. And after the successful testing of the full configuration with 12 bays, you will set the base which are not available yet to the general to the here you will find here sets the proxy bay in the 7SS85CU, and here you have the out of service, that's the functionality I explained before, and here you have the mode, mode control level which you can set to off. Reaction, all functions assigned to the SPAY inside the SPAY, doesn't matter, it will not be, it's like the bay unit allocation in the 7SS52 when you set the bay unit allocation to none. So really the complete bay is switched off. No signal will come from the SPAY, no warnings that no measurements will come from the SPAY. The SPAY is like not available in your configuration. Okay, then of course, when the additional base in 1, 2, 3, 4 years will be available, then you will simply set this mode once again to 1, and everything will be fine. And it's not necessary once again to make a testing of the configuration. Of course, you should test the correct wiring of the device to your primary substation, to the primary equipment. Maintenance function, acquisition blocking and manual update. This acquisition blocking in the 7SS52 was called the revision mode, but this functionality was already in SIPROTEC 5 introduced as acquisition blocking, and because now in SIPROTEC 5 we are more embedded really in the system family compared to SIPROTEC 4 with the 7SS52. So we changed this name from revision mode also to acquisition blocking. The application is really to freeze the disconnector image, to make it independent really from the positions from the auxiliary contact of the disconnectors of the circuit breakers. This may be the case and must be done when the auxiliary contacts of the disconnector circuit breakers will be maintained, or when the auxiliary voltage of the SPAY for the disconnectors is switched off for maintenance. Of course, during this time, no primary switching should be done, because otherwise you will get differential current in the selective zones, and hopefully against a wrong tripping, the check zone will help you, or not hopefully, it will nevertheless protect you against the wrong tripping, the check zone. But nevertheless, once again, busbar protection, no single fault should lead to a wrong tripping of a busbar protection. We want only to have 2 security mechanisms to prevent a wrong tripping. Reaction. The status of the selected disconnector is frozen. The current assignment to the selective zones, of course, and also to the check zone remains. To the check zone it remains anyway. And the supervision of the affected disconnection, so we have no longer supervision of the runtime. And we get a signal and alarm acquisition blocking. After acquisition blocking, it's only possible after acquisition blocking, you can make a manual update, so you can simulate a disconnector image different really to the primary, maybe for testing purposes or anything else. This is only possible via HMI, but via HMI, of course, if you think about our web browser, you can go via the web browser to the HMI of the device, and then you can do it via the web browser also to make a manual update of the disconnector positions. Blocking binary outputs for test purposes. I thought this question was already done in advance. I hope I can give no answer. There are more possibilities. I will here show only one possibility, which are busbar protection specific. You can also do, just to mention it, to make this blocking of binary outputs like IEC 61850 with this BO blocked and so on. That's also possible, but I think that's a general IEC 61850 topic. This can be used also for busbar protection, but I want to explain here really the busbar protection specific ways to block binary outputs. The first way, using the test mode, to be honest, is also not busbar protection specific. You can activate the test mode of the complete device. And here you are activating the complete device into test mode, but you are activating not the test mode for your binary outputs. And this has the effect that you can really run completely, make your test. You will see all your trips. If you simulate a trip, if you are injecting any differential current, you will see the trip. You can test a circuit breaker, and you will see all signals you want to test, but no binary output will be activated because all signals are flagged with the test mode. And as the binary outputs are not under test mode, signals with the test flag will not activate binary outputs without test mode, and so you will not risk any tripping by binary outputs if you bring the device completely into test mode. You have to care that also, and you have to know if you are in test mode, all signals sent to a substation communication will be also flagged, of course, with the test mode. A very specific implementation of busbar, of blocking on the busbar protection trips. That's a little bit in the way we have implemented also in the 7SS52, and especially working together to have a busbar protection with busbar protection with full line protection device using as a bay unit for the busbar protection, and you want to test only the busbar protection, but the feeder protection, the line protection should really completely work. And therefore we have a setting, block only busbar protection relay trips. So this blocks a trip of the busbar differential protection. It blocks a busbar trip after a circuit breaker failure protection. If you remember, we have the circuit breaker failure protection. We have a retrip T2, and this will lead to a complete tripping of the bus zone associated, connected to this bay. And also here, for such a trip of the circuit breaker failure protection, we will have a blocking of the binary outputs. And the same also if you have an external trip of a bus zone. What not will be blocked, an overcurrent protection, it will not be blocked also from the circuit breaker failure protection, the retrip. I am finished. Nina, come to we are at the end.
No, you're not yet done.
Nearly done.
Nearly done.
The questions will all answer Nina now.
Okay, once again, yeah, well, I mean, that's why we have two experts here. Let's see. Currently I see one more question, and I think by now you've got a lot of input, but let's see. VS wants to know, is it possible to order trainings for factory personnel, like for the basic parameterization of SIPROTEC 5? And I think the simple answer is yes, via the Power Academy. And I fear that you can take a look at my moderator cards right here, because there's a big button, Power Academy trainings. Yes, we do have this Power Academy, and you can book there the trainings. And if you do a training in the Power Academy, it's even a bit a deeper dive. It's a hand-on for you. And you will surely receive a certification there of your successful participation. So thanks for the answer. And thanks a lot for all the other answers. They were really helpful once again to keep this a vivid round. I hope you enjoyed the webinar and the content we shared. And oh, now that's a complicated question coming in, huh? Let's see. VB wants to know something about the operating state. So the base mode to off prepares the future bay. Okay, that's a nice feature, but is it possible to switch off, for example, the breaker or disconnector separately or individually? Like in a reliant system. The current situation is that the bay is equipped with bus disconnectors, but a bay breaker is missing and not built in. Oh, so that's, I think, a very special question, right? And it's okay if we take it offline, but if you see it easy to answer, that's also okay. No, you don't look like an easy answer here. So I think we take this.
I do not completely understand really.
Then we'll take the question
let's
offline
take away it here
and go in a 101 discussion, because I think that's better helpful. You've stayed for quite a long time with us, and we definitely thank you for that. You will get access to the recording and to the presentation. And if I remember it correctly, right here, right behind us, and maybe in front of us if you see it enlarged for later on. You get additional information on our webinars we offer on the webinar registration page. You also see there the link to the Power Academy trainings I already mentioned. And so for today, I hope that you enjoyed the tour with us, deepened your knowledge around the busbar protection. Today, we've learned a lot about the application of the distributed configuration and quite a lot of knowledge around supervision and maintenance functions. I hope you can make use of that, protect your assets, keep your systems protected. And as you already know, if there are still unanswered questions, will be homework to the experts. But today we'll say goodbye for now, stay safe, meet us in one or the other electrification and automation webinars, and ask the experts if questions come to mind later. Goodbye.
Goodbye.
Bye.